Despite the fact that their most fundamental and crucial function, launching and landing fighter jets on a ship in the middle of the ocean proves to be a highly challenging undertaking. Aircraft carriers have been the focal point of the US Navy. Engineers had to create strong technologies to accelerate and decelerate aircraft quickly since there is a severe lack of runway area on the decks of these mobile vehicles. You might be surprised to learn that even in choppy waters and when the ship is moving and rocking from side to side, helicopters can routinely and safely land on the flight deck of smaller ships. Although there is minimal room for error, the landing is a little more unusual than you may expect. However, mistakes can still happen, which is why there are two conventional emergency protocols for helicopters that are unable to land on a ship's deck. Hey there, and welcome to another episode of High Technology. Before we ride along the vast ocean up in the air, feel free to join the club as we unravel high-end technologies on the planet by subscribing to this channel and hitting the notification bell so you won't miss any exciting videos in the future. Without further ado, here's a close look of how pilots land and take off in rough seas on aircraft carriers. First, pilots have to launch from a catapult. In order for an airplane to accelerate quickly enough to take off, long runways are frequently necessary. Despite the fact that the runway length on an aircraft carrier is only about 400 feet as opposed to the 2,300 feet needed for normal aircraft to take off from a runway, engineers have developed steam-powered catapults on the decks of aircraft carriers that can launch aircrafts from 0 to 150 knots or 170 miles per hour in just 2 seconds. The takeoff system is built on two elements: above ground and below ground operations. Above ground, the front wheel or nose gear of the aircraft are fastened to the catapult above deck by the crew using a tow bar. To enable the catapult to draw the plane, the toolbar is fastened to the front of the nose gear. Directly behind the aircraft, a jet blast deflector directs the jet discharge upward into the air, keeping the dangerous jet discharge from impacting unfavorable areas. Then the pilot accelerates the engine to its maximum power, producing the forward thrust required to move a jet ahead normally. Once the thrust of the jet is paired with the additional force from the catapult, the holdback bar will disengage and the aircraft will move. The holdback bar can only withstand the force of a jet operating at maximum thrust. It cannot withstand the force of a catapult. During below ground, at extremely high pressures, below ground steam is poured into the capsule below deck. Every time a valve is opened, steam is forced up a long tube that runs the whole length of the catapult. Numerous pistons receive the steam pressure and are then maintained in place until the release instruction is given. The pistons are connected to the catapult above by a pulley system that is installed in a crack that runs the entire length of the runway. Once the plane is at full throttle and the steam has built up pressure below deck, the pistons are released and thrust forward. The holdback device, which is only intended to hold the force from the jet's drive to release and send the jet into the air, is compelled to disengage as a result. Once the catapult has finished its task, it must be quickly stopped. A water braking system is installed at the end of the launch tube. The pressure in the tube causes the pistons to quickly come to rest when they contact the water brake. When the next aircraft is ready to launch, the pulley system quickly retracts the catapult. The retracting piston forces the steam through the separate tube so it can be heated up and utilized again for subsequent launches. The process takes about approximately a minute to finish. Jumping on the procedure for landing. For a Navy pilot, landing aboard an aircraft carrier is the most challenging undertaking. The pilot must precisely align the aircraft with the runway, approach at a precise angle, and quickly come to a stop for a successful landing. Most people would find this horrifying, but engineers have created two tools to help them: the Fresnel lens and the arresting wires. Correct landing on an aircraft carrier is guided by the optical landing system with Fresnel lenses. It is situated such that the pilots can see it as they approach the runway and land. The optical landing system is made up of a horizontal bar of green lights and a vertical bar of red lights on either side of the meatball. 5 amber-colored lenses that make up the meatball, the centerpiece, are assembled. Some lenses will light up one at a time, depending on the plane's angle with the meatball. The horizontal green bars on the side seem to move up and down around the main light. To ensure a safe landing, the pilot makes every effort to maintain the green bar and the center amber power lens horizontal during the landing operation. The amber light will become red if the pilot flies too low, indicating that the aircraft is dangerously near to the rear of the aircraft carrier. The red lights around the green horizontal bars will flash to indicate that the jet must continue circling or find another landing location if the ship is unable to handle the aircraft. Finally, for pilots, the touchdown and the following deceleration brought on by the arresting wires are the most challenging parts. This landing technique calls for extraordinary skill, but it also largely depends on the ground's crew ability to execute it, without making any mistakes of course. Just before touchdown, the pilot releases the tailhook. A long metallic bar that hangs a few inches above is the carrier's tail. When the airplane lands, the hooked end of the tail hooks one of the 4 arresting lines, stopping the surface of the aircraft. Despite the wire's straightforward design, there is a high likelihood that anything may go wrong. The second or third cables, as opposed to the first or fourth, are the ones that good pilots aim for because they will prevent a collision with the carrier's back and still allow for takeoff if they miss their target. As soon as the wheels make contact with the deck, the pilot accelerates the aircraft to full speed. This is done to make sure that the plane can still take off on time from the end of the runway even if the tailhook misses the arresting wires. A member of the crew responsible for the arresting gear enters and double checks the arriving jet's weight and specifications prior to the plane's arrival. If their weight is entered too high, the plane could crash if it lands too soon and sustain damage. The plane won't be able to stop in time and will crash into the water if the weight is inputted too low, which is even worse. Despite the fact that there is always a chance of tragedy, it is rare because of extensive training and preparation. If everything goes as planned and the arresting cable is deployed, the cable will be dragged out through the deck, slowing the aircraft. The cable is attached at both ends to a piston housed inside a cylinder that runs parallel to the deck wires above. This mechanism is powered by pulley systems. Depending on the entire mass of the object they are supporting, different amounts of liquid are poured inside the cylinder. When the wire is pressed, the pistons move through the tube and eventually force the fluid out of the cylinder. As the wire is pulled, this happens. The fluid's force makes the piston's initial push less powerful, which causes the arresting wires and the corresponding plane to move more slowly. The tailhook will be unhooked and the arresting wires will be retracted when the aircraft has completely stopped and the engines have been shut off, so they are ready for the next aircraft to land. What are your thoughts with this? Not only dangerous but challenging task? Would you ever step up on the job flying a chopper and landing or taking off an aircraft carrier? Indeed, you have nothing to worry about. Our modern technology has served us well. The Navy is showcasing how straightforward but effective the original design concepts actually are by using the present technologies as the blueprint for the future designs. An aircraft carrier built by engineers has stood the test of time and will be in operation in some capacity for a very long time. And that's a wrap for today's video. We hope this has been insightful to you. If you enjoyed watching, give this a thumbs up and hit that subscribe button together with the notification bell so you won't miss any incredible videos. This has been High Technology, serving you the best and cutting edge contents on the highest form of technology available on the planet. We'll see you on the next one.